By 2037, air passenger numbers could double to 8.2 billion, a staggering increase that will see airports and airlines busier than ever before. This surge in demand isn't just a statistic, it represents millions of new journeys, more flights crisscrossing the globe, and a dramatic rise in the need for efficient, reliable air travel. This explosive growth is putting immense pressure on the aviation industry to expand, modernize, and crucially, to do so sustainably. The industry faces a dual challenge, accommodating this unprecedented surge in passengers and flights, while simultaneously slashing its environmental impact to help combat climate change. Aviation already accounts for 2 to 3% of global CO2 emissions, a figure that may seem small but is significant given the sector's rapid growth. As other industries decarbonize and reduce their carbon footprints, aviation's share of global emissions is set to rise, making it a focal point in the fight for a cleaner planet. The need for innovation is urgent. This is an environmental necessity, not just a business strategy. The world is watching, and the pressure to deliver real solutions has never been greater. Enter the Rolls-Royce UltraFan, not just another engine in the lineup, but a radical rethinking of gas turbine design. Built from the ground up to address the challenges of tomorrow's aviation, decades of research, relentless testing, and billions in investment have gone into making UltraFan the foundation for a new era of efficient, eco-friendly flight. Rolls-Royce targets a 25% leap in fuel efficiency over its first-generation Trent engines, a monumental advance in a field where even small gains are big news and can mean millions in savings and tons less CO2. UltraFan is validated to run on 100% sustainable aviation fuel from day one, ensuring it's ready for the fuels of the future as soon as they become widely available. In this way, UltraFan bridges today's needs with tomorrow's green solutions, helping airlines transition smoothly to a more sustainable future. The UF001 demonstrator's successful 2023 run in Derby, UK, proved the viability of its integrated novel technologies, setting a new benchmark for what's possible in jet propulsion. From its massive lightweight composite fan to its revolutionary power gearbox, every part of UltraFan pushes the boundaries of what's possible in aviation engineering, setting new standards for performance and sustainability. UltraFan's impact could reshape the economics and sustainability of long-haul air travel for decades to come, making cleaner skies a reality for future generations. Let's dive deeper into what makes this engine a true game-changer for the aviation industry and the planet. To grasp UltraFan's significance, consider its heritage. Rolls-Royce's three-shaft architecture has set its engines apart for decades, powering icons like the Airbus A350 and Boeing 787. Unlike twin-shaft designs, three shafts let each compressor and turbine spin at optimal speeds, boosting efficiency. The Trent series built a reputation for reliability and performance, with each generation pushing bypass and pressure ratios higher. UltraFan is the next leap, retaining three-shaft benefits but adding a game-changing power gearbox. Traditionally, large turbofans were direct drive, forcing a compromise between fan and turbine speeds. UltraFan's gearbox decouples them, enabling a much higher bypass ratio and greater efficiency. This innovation allows a larger, slower fan, moving more air with less energy. But building a gearbox for such power was a massive engineering challenge. At the very heart of the UltraFan engine lies its revolutionary power gearbox, a planetary gear system capable of handling an astonishing 64 megawatts of power, setting a new world record in aerospace engineering. This gearbox is not just a component, it's a technological leap that redefines what's possible in jet propulsion. The power gearbox allows the UltraFan's massive 140-inch fan to rotate slowly, while the core turbine spins at much higher speeds. This unique arrangement enables a bypass ratio greater than 15:1, dramatically improving efficiency and performance compared to previous engine designs. Achieving this breakthrough required the development of entirely new materials, state-of-the-art lubrication systems, and intricate engineering to manage the immense mechanical forces and extreme heat generated within the gearbox. The planetary gears inside the gearbox distribute these massive loads evenly across multiple contact points, ensuring both exceptional durability and long-term reliability, even under the most demanding conditions. This engineering breakthrough finally solves a decades-old compromise in jet engine design, unlocking unprecedented levels of propulsive efficiency and paving the way for the next generation of sustainable aviation. When paired with the Advanced 3 core, the UltraFan achieves record-setting thermal efficiency, operating at higher pressures and temperatures than any previous commercial engine. Next-generation materials and innovative cooling technologies allow engineers to extract more energy from every drop of fuel, pushing the boundaries of what jet engines can achieve. The seamless synergy between the power gearbox and the advanced core is what delivers UltraFan's dramatic reduction in fuel burn, making it one of the most efficient engines ever built. Thanks to the slower fan speeds enabled by the gearbox, UltraFan also reduces noise by up to 35% compared to earlier engines, making flights significantly quieter for airport communities and those living nearby. With these innovations, UltraFan sets a bold new standard for integrated, efficient, and quiet propulsion, shaping the future of aviation for decades to come. UltraFan's ambitious targets demanded new materials, pushing the boundaries of what was previously thought possible in aerospace engineering. Its 140-inch fan blades use carbon titanium composite, carbon fiber with a titanium leading edge, making them significantly lighter and stronger than previous designs, revolutionizing the way we think about fan blade construction. This weight reduction not only lowers fuel burn but also allows for a lighter containment case, compounding efficiency gains and enhancing overall performance. The titanium edge is designed to resist erosion and withstand bird strikes, while the carbon fiber ensures the blades remain light and agile. Deeper inside the engine, ceramic matrix composites, CMCs, are utilized in the hot turbine sections, where temperatures soar. CMCs are 1/3 the weight of traditional nickel alloys and can withstand much higher temperatures, making them ideal for high-performance applications. This capability allows the engine to run hotter, significantly boosting thermal efficiency and reducing overall fuel consumption. CMCs also require less cooling air, meaning more air stays in the main cycle, further improving the engine's efficiency and performance. These advanced materials are key to UltraFan's step change in performance, enabling it to achieve unprecedented levels of efficiency. They enable higher core temperatures, lower weight, and greater fuel savings, which are crucial for modern aviation demands. UltraFan's material innovations are as revolutionary as its architecture, setting a new standard for the future of aerospace technology. UltraFan's headline achievement is a 25% fuel burn improvement over the first-generation Trent 700. This leap is driven by its ultra-high bypass ratio, 15:1 compared to 10:1 for the latest Trent XWB. Moving more air more slowly means higher propulsive efficiency and lower emissions. UltraFan's scalable design can power a range of future aircraft, from 25,000 to 110,000 pounds of thrust. For airlines, this means billions in fuel savings and a major cut in CO2 emissions. Lower fuel costs could translate to cheaper fares and more accessible air travel. UltraFan's efficiency isn't just a technical milestone, it's a transformative force for the industry. It directly addresses aviation's biggest environmental and economic challenges. UltraFan is designed for 100% sustainable aviation fuel, SAF, from day one. SAF, made from renewable sources, can cut lifecycle CO2 emissions by up to 80% compared to conventional jet fuel. UltraFan's first full-power run used pure SAF, proving the technology is ready for a greener future. This readiness encourages fuel producers and regulators to scale up SAF supply. The engine's advanced combustor also slashes nitrogen oxide and particulate emissions. Rolls-Royce targets a 40% reduction in NOx compared to current limits. UltraFan's green credentials give airlines a competitive edge as sustainability becomes a key market driver. It's a comprehensive solution for aviation's environmental impact, ready for the next era. UltraFan's arrival could transform the wide-body aircraft market. Its efficiency could spark new aircraft programs with airframes designed to maximize its benefits. The engine's scalability means it could power everything from next-gen narrowbodies to the largest wide-body jets. Rolls-Royce could become a key partner for multiple future aircraft families. UltraFan's large fan diameter challenges airframe design, requiring longer landing gear and potentially new wing shapes. This interplay will drive innovation in both engines and aircraft. The competitive landscape among engine makers will shift, with UltraFan's geared architecture offering a distinct path. UltraFan isn't just an engine, it's a catalyst for the next generation of aircraft design. UltraFan's commercial debut will ripple across aviation. Airlines will see immediate cost savings, enabling new long-haul routes and competitive fares. Fleets powered by UltraFan will have a clear edge over older, less efficient aircraft. Manufacturers face both opportunity and challenge. Integrating UltraFan means rethinking airframe design. But the payoff is market dominance. Passengers will notice quieter cabins and more direct, non-stop flights. Maintenance will shift to a data-driven model, with UltraFan's smart sensors enabling predictive on-condition servicing. MRO providers must adapt, investing in digital tools and training for these advanced engines. The UltraFan ecosystem will transform not just flight, but the entire aviation value chain. It's a leap forward for airlines, manufacturers, passengers, and service providers alike. UltraFan is set to redefine what's possible in commercial aviation. UltraFan isn't just an engine, it's a revolution in propulsion. Its geared architecture, advanced core, and cutting-edge materials set new standards for efficiency and sustainability. With a 25% fuel efficiency gain and 100% SAF capability, UltraFan is a vital tool for aviation's net-zero ambitions. It bridges today's needs with tomorrow's green technologies like hydrogen and electric flight. For airlines, manufacturers, and passengers, it promises quieter, cleaner, and more affordable travel. The challenge now: can the industry scale up SAF production fast enough to realize UltraFan's full decarbonization potential? The future of green aviation depends on it.